Welcome to episode 23 of AI.COOKING, a podcast about artificial intelligence.
Hello, meatbags. Welcome to AI.COOKING, episode 23. A podcast about artificial intelligence. I am Gregory William Forsyth Foreman or Gwoof from the Kingdom of Kent or the Cock. Together that makes Gwoof the Cock. And I will bring you news about artificial intelligence from the second half of January 2022 and AI Knowledge Corner! Trying to get that to sound like one of them old school toys with the little helicopters with a few buttons on the side, and you press them and you press them and you press them, and there's one that sounds like, beep. So yes, I, Gwoof the Cock. I'm good, very good. Trying to get pub number 4 up and running. Now listen, I have got a message to tell everyone in the world everywhere. The first person from the nation, that is the No Agenda Nation, Gitmo Nation, who can make it to my 4th pub can have it. Yes, there you go. A whole pub for you to have. With certain terms and conditions, obviously. So, let's talk news. AI light field camera reads 3D facial expressions. Machine-learned light field camera reads facial expressions from high-contrast illumination invariant 3D facial images. A joint research team led by Professors Ki-Han Huan and Do-Hyun Lee from the Department of Bio and Brain Engineering of the Korea Advanced Institute of Science and Technology reported the development of a technique for facial expression detection by merging near-infrared light field camera techniques with artificial intelligence technology. Yes, our favourite. Why everyone turns up here right now to hear this sort of stuff about AI. The facial expressions in the acquired 3D images were distinguished through machine learning with an average of 85% accuracy. A statistically significant figure compared to when 2D images were used. Furthermore, by calculating the interdependency of distance information that varies with facial expression in 3D images, the team could identify the information a light field camera utilizes to distinguish human expressions. Professor Ki-Han Zhuang said, "The sub-miniature light-field camera developed by the research team has the potential to become the new platform to quantitatively analyze the facial expressions and emotions of humans." To highlight the significance of this research, he added, "It could be applied in various fields including mobile healthcare, field diagnosis, social cognition, and human-machine interactions." Thought I'd put a little sort of crazy scientist voice on that one. Just fresh off watching a Hotel Transylvania 4 with my daughter. And thought I'd got a bit Transylvanian on you. I hope that doesn't offend anyone from that particular region of the world. In other news, jobs for machine learning engineers are growing fast, according to an analysis by LinkedIn. Machine learning engineer ranks 4th among the 25 fastest growing job titles in the United States, according to the Professional Social Network's annual Jobs on the Rise report. Open parentheses, the top 3 were vaccine specialist, diversity and inclusion manager, and customer marketing manager. Just to report, the top 3 were vaccine specialist, Diversity and Inclusion Manager, and Customer Marketing Manager. Learn to code, people! Learn to code! Salaries for machine learning engineers generally ranged from $72,600 per annum to $170,000 per annum. Applicants were expected to have a median of 4 years of prior experience. Skills requested most often included deep learning, natural language processing, and TensorFlow. Most jobs were located in San Francisco, Seattle, and Los Angeles, and nearly 20% of them allowed remote work. Of machine learning engineers who previously held a different title, most had been software engineers, data scientists, or AI specialists. Yes, get these jobs going whilst you can. I've got me a job in AI. Look at me here, reading the news for the AI people. And in item 3, over to everyone's favourite super corporation. Amazon's first brick-and-mortar clothing store is getting ready to deliver automated outfit recommendations. Has anyone seen Bezos's wardrobe? How decent is his wardrobe? Has he got more than one turtleneck, like black turtleneck? That's what tech giants wear these days, or yesteryear days. The e-commerce giant announced plans to open a flagship Amazon-style location at a Los Angeles area mall this year. The 30,000 square foot store will feature aisles and racks like a traditional clothing store, but customers will be able to scan QR codes using their phones to see variations in colour and size, as well as items recommended by machine learning models. A touchscreen in each fitting room will enable customers to request such items to try on. I wonder if the touchscreen will have one of those nifty little front-facing cameras so that you can see yourself in different colours of different stuff. I wonder if that front-facing camera will be in changing rooms of Amazon-style places. Amazon Style. What a naff name if that's what they're going for. I'm sure they won't. They'll probably go for something like Pantheon. Swiftly moving on to one of our other super corporations. Yiping Chen and colleagues at Microsoft devised Mobile Former, an image recognition system that efficiently weds a mobile net's convolutional eye for detail with a Vision Transformer's attention-driven grasp of the big picture. Mobile Former is a stack of layers, each made up of 3 components. A mobile net block and transformer block joined by a two-way bridge of 2 attention layers, one for each direction of communication. The mobile net blocks refine an image representation. The transformer blocks refine a set of 6 tokens, randomly initiated vectors that are learned over training, and the bridge further refines the image representation according to the tokens and vice versa. The authors trained the system on ImageNet. Mobile Former beat competitors at a similar computational budget and at much larger budgets as well. In ImageNet classification, it achieved 77.9% accuracy using 294 megaflops, a measure of computational operations, beating transformers that required much more computation. I have to be honest, even after all these months, there's very little of that I actually comprehended or understood. And coming in at number 5, which is halfway through your total number of news items this fortnight, Transformers C in 3D. Ooh. Visual robots typically perceive the 3-dimensional world through sequences of 2-dimensional images, but they don't always know what they're looking at. For instance, Tesla's self-driving system has been known to mistake a full moon for a traffic light. To the moon! New research aims to clear up such confusion. What's new? Aljaz Bozik and colleagues at Technical University of Munich released Transformer Fusion, which set a new state-of-the-art in deriving 3D scenes from 2D video. Given a series of 2D frames, Transformer Fusion learned to reconstruct the 3D space they depicted by classifying whether each 3D pixel or voxel belonged, or was very close, to an object's surface. The authors trained the system on ScanNet, a dataset that contains RGBD, video plus depth, clips shot in indoor settings like bedrooms, offices, and libraries, object segmentations, and 3D scene reconstructions. Despite setting a new state-of-the-art, Transformer Fusion's ability to visualize 3D scenes falls far short of human-level performance. Its scene reconstructions are distorted, and it has trouble recognizing transparent objects. Oh, that's good then, to run away from the robots for now. You just gotta be see-through. Coming in at number 6. Robots learn to hike in Switzerland. Steep sections on slippery ground, high steps, scree and forest trails full of roots. The path up the 1,098-metre-high Mount Etzel at the southern end of Lake Zurich is peppered with numerous obstacles. But Animal, the quadrupedal robot from the Robotic Systems Lab at ETH Zurich, overcomes the 120 vertical meters effortlessly in a 31-minute hike. That's 4 minutes faster than the estimated duration for human hikers, with no falls or missteps. This is made possible by a new control technology, which researchers at ETH Zurich, led by robotics professor Marco Hutter, recently presented in the journal Science Robotics. The robot has learned to combine visual perception of its environment with a proprioception, its sense of touch, based on direct leg contact. This allows it to tackle rough terrain faster and more efficiently, above all, more robustly, Hutter says. In the future, Animal can be used anywhere that is too dangerous for humans or too impassable for other robots. Ah, darn. So you're telling me that if robot robbers, burglars of the sort of variety that was in the popular movie Home Alone won't be fooled by a bunch of Lego on the floor as they come in through the window? That's plan number 1, Scarped, isn't it? More information for you now in Article 7, Data-to-Vec, a general framework for self-supervised learning in speech, vision, and language. While the general idea of self-supervised learning is identical across modalities, the actual algorithms and objectives differ widely because they were developed with a single modality in mind. Data-to-Vec, a new framework has been presented that uses the same learning method for either speech, NLP, or computer vision. The core idea is to predict latent representations of the full input data based on a masked view of the input in a self-distillation setup using a standard transformer architecture. Yeah, what he just said. Instead of predicting modality-specific targets such as words, visual tokens, or units of human speech which are local in nature, Data-to-Vec predicts contextualized latent representations that contain information from the entire input. Experiments on the major benchmarks of speech recognition, image classification, and natural language understanding demonstrate a new state-of-the-art or competitive performance to predominant approaches. And shifting over to item number 8, language models as zero-shot planners, extracting actionable knowledge for embodied agents. Can world knowledge learned by large language models or LLMs be used to act in interactive environments? In a new paper by University of California, Berkeley, Carnegie Mellon University, and Google Brain, the possibility of grounding high-level tasks has been investigated, expressed in natural language, e.g., make breakfast, to a chosen set of actionable steps, e.g., open fridge. While prior work focused on learning from explicit, step-by-step examples of how to act, the new paper surprisingly finds that if pre-trained LMs are large enough and prompted appropriately, they can effectively decompose high-level tasks into low-level plans without any further training. However, the plans produced naively by LLMs often can't map precisely to admissible actions. The new paper proposes a procedure that conditions on existing demonstrations and semantically translates the plans to admissible actions. Evaluation in the recent virtual home environment shows that the resulting method substantially improves executability over the LLM baseline. The conducted human evaluation reveals a trade-off between executability and correctness, but shows a promising sign towards extracting actionable knowledge from language models. Sneaking a stealth article in here, IBM sells Watson Health assets to investment firm Francisco Partners. IBM is selling parts of its Watson Health unit to the global investment firm Francisco Partners. The company's confirmed Friday. The deal is expected to close in the second quarter of this year. Terms were not disclosed. Under the agreement, Francisco Partners will acquire specific healthcare data and analytics assets that are part of the Watson Health business. These include datasets and products like Health Insights, Market Scan, Clinical Development, Social Program Management, Micromedics, and imaging software offerings. Just for the info, Watson is a question-answering computer system capable of answering questions posed in natural language, developed in IBM's DeepQA project by a research team led by principal investigator David Ferrucci. Watson was named after IBM's founder and first CEO, industrialist Thomas J. Watson. And for your penultimate news article this fortnight, global artificial intelligence in beauty and cosmetics market worth $13.34 billion US dollars or buckaroos by 2030, says a report by Insight Ace Analytic. The beauty and cosmetic sector have witnessed a massive upsurge in artificial intelligence in recent years, due to advancements in AI technologies and the fact that beauty is characterized as a personalized and engaging market that generates a large amount of data. AI appears to be a solution to deal with this complex environment, prompting beauty companies to make data-driven decisions on their strategies to remain competitive. The beauty market has changed dramatically over the last decade, owing to the introduction of new technology and a shift in customer shopping behaviors. The beauty sector has been incorporating digital transformation into its business models to give consumers individualized skin regimens and beauty products tailored to their specific needs. The artificial intelligence in beauty and cosmetics market growth can be attributed to the integration of advanced technology like AI in the beauty and cosmetic field, providing new ways of engaging with the consumer, bringing efficiency and customized solutions to the beauty client, such as virtual try-on and personalized products. Increased demand for beauty products and technological advancements is expected to positively impact market growth. The outbreak of COVID-19 has changed consumer purchasing patterns across the beauty and cosmetic industry due to strict lockdown situations and the practice of social distancing across various countries. However, the COVID-19 crisis is likely to create opportunities for beauty and cosmetic brands due to the growing demand for personalized beauty and cosmetic products and the rapidly evolving e-commerce sector. You guys, you're beautiful in your own skin, all right? Everyone's stunning in their own skin, and you can just work it, baby. Seriously, it's all about that inner confidence. I mean, it's easy for someone so angelic as your Guff the Cock here to say, obviously. But yeah, come on now. Oh, carpe diem. Beauty's in the eye of the beholder. You can do it. Go get 'em, Tiger. Finally, more predictions for the year 2022. DeepMind's next steps. One of the biggest AI breakthroughs in the last couple of years has come from London-headquartered research lab DeepMind, which is owned by Alphabet, parent company of Google. The company has successfully created AI software that can accurately predict the structure that proteins will fold into in a matter of days, solving a 50-year-old grand challenge that could pave the way for better understanding of diseases and drug discovery. Neil Lawrence, a professor of machine learning at the University of Cambridge, said that he expects to see DeepMind target more big science questions in 2022. Language models, AI systems that can generate convincing text, converse with humans, respond to questions, and more, are also set to improve in 2022. The best-known language model is OpenAI's GPT-3, but DeepMind said in December that its new retro language model can beat others 25 times its size. Catherine Breslin, a machine learning scientist who used to work on Amazon Alexa, thinks big tech will race towards larger and larger language models this year. Breslin, who now runs AI consultancy firm Kingfisher Labs, said that there will be also a move towards models that combine vision, speech, and language capability, rather than treat them as separate tasks. Finally, the Knowledge Corner! Sometimes it's good to take a shallow look at something too. So here we present a list of popular terms and definitions related to artificial intelligence. A is for algorithms. A set of rules or instructions given to an AI, neural network, or other machines to help it learn on its own. Classification, clustering, recommendation, and regression are four of the most popular types. A is for artificial intelligence. A machine's ability to make decisions and perform tasks that simulate human intelligence and behavior. A is for artificial neural network, or ANN, AN. A learning model created to act like a human brain that solves tasks that are too difficult for traditional computer systems to solve. A is for autonomic computing. A system's capacity for adapted self-management of its own resources for high-level computing functions without user input. C is for chatbots. A chat robot, chatbot for short, that is designed to simulate a conversation with human users by communicating through text chats, voice commands, or both. They are a commonly used interface for computer programs that include AI capabilities. C is for classification. Classification algorithms let machines assign a category to a data point based on training data. C is for cluster analysis. A type of unsupervised learning used for exploratory data analysis to find hidden patterns or grouping in data. Clusters are modeled with a measure of similarity defined by metrics such as Euclidean or probabilistic distance. C is for clustering. Clustering algorithms let machines group data points or items into groups with similar characteristics. C is for cognitive computing. A computerized model that mimics the way the human brain thinks. It involves self-learning through the use of data mining, natural language processing, and pattern recognition. C is for convolutional neural network, or CNN. A type of neural networks that identifies and makes sense of images. D is for data mining. The examination of datasets to discover and mine patterns from that data that can be of further use. D is for data science. An interdisciplinary field that combines scientific methods, systems, and processes from statistics, information science, and computer science to provide insight into phenomenon via either structured or unstructured data. D is for decision tree. A tree and branch-based model used to map decisions and their possible consequences, similar to a flowchart. D is for deep learning. The ability for machines to autonomously mimic human thought patterns through artificial neural networks composed of cascading layers of information. F is for fluent. A type of condition that can change over time. G is for game AI. A form of AI specific to gaming that uses an algorithm to replace randomness. It is a computational behavior used in non-player characters to generate human-like intelligence and reaction-based actions taken by the player. G is also for genetic algorithm. An evolutionary algorithm based on principles of genetics and natural selection that is used to find optimal or near-optimal solutions to difficult problems that would otherwise take decades to solve. H is for heuristic search techniques. Support that narrows down the search for optimal solutions for a problem by eliminating options that are incorrect. K is for knowledge engineering. Focuses on building knowledge-based systems, including all of the scientific, technical, and social aspects of it. L is for logic programming. A type of programming paradigm in which computation is carried out based on the knowledge repository of facts and rules. Lisp and Prolog are two logic programming languages used for AI programming. M is for machine intelligence. An umbrella term that encompasses machine learning, deep learning, and classical learning algorithms. M is for machine learning. a facet of AI that focuses on algorithms, allowing machines to learn without being programmed and changed when exposed to new data. M is for machine perception. The ability for a system to receive and interpret data from the outside world similarly to how humans use our senses. This is typically done with attached hardware, though software is also usable. N is for natural language processing. The ability for a program to recognize human communication as it is meant to be understood. R is for recurrent neural network, or RNN. A type of neural network that makes sense of sequential information and recognizes patterns, and creates outputs based on those calculations. S is for supervised learning. A type of machine learning in which output datasets train the machine to generate the desired algorithms, like a teacher supervising a student, more common than unsupervised learning. S is for swarm behavior. From the perspective of the mathematical modeler, it is an emergent behavior arising from simple rules that are followed by individuals and does not involve any central coordination. U is for unsupervised learning. A type of machine learning algorithm used to draw inferences from datasets consisting of input data without labeled responses. The most common unsupervised learning method is cluster analysis. And that's it for this episode. Stay safe, clump, and stay dangerous. Meatbag. The singularity is near!